Hey guys, before we talk about how to draft rational function, I want to quickly talk about how to find the asymptote of rational function. So let's go. Hey guys, and welcome back to another video. My name is Franck, and if you have not done so yet, go ahead and subscribe to the channel so you can get more videos like this. Today we are going to learn how to find asymptotes of rational functions. Those are going to be vertical asymptotes, horizontal asymptote, and also oblique or slanted asymptote. So to begin with, a rational function is one that's written as f of x equals to p of x divided by q of x, where p of x and q of x are polynomials. In this case, q of x should not be equal to 0. Otherwise, this function would not exist. So first thing that we're going to talk about here is how to find vertical asymptotes. And you can do that in two steps. The first thing you should do is to simplify the rational function completely. And then the second thing you should do is locate the x where the denominator is equal to 0. And so if I give you an example here, I have f of x equals to x divided by x squared minus 9. And so that, if I wanted to simplify it, I would have to factor the denominator and the numerator. That's going to give me x on top, and on the bottom, since I have a differences of squared, I'm going to have x minus 3 in parentheses, x plus 3. And with that, you can clearly see that here, this is completely simplified. And so the x that will make the denominator 0 here are x equals to 3 from the first factor on the bottom, and x equals to negative 3 from the second factor on the bottom. And so those two lines, which happens to be vertical lines, would be our vertical asymptotes in this case. Next example I have is going to be g of x is equal to x plus 7 divided by x squared plus 4x minus 21. And so in this case, on the top, you're still going to have x plus 7, but on the bottom, you're going to see that this is a quadratic. And so that means that I need to find two numbers that are adding up to 4 and multiplying to 21. And so that's going to be 7 and negative 3. So I'm going to have here x plus 7 and x minus 3. And so with that, you can simplify the x plus 7 on top and the bottom, and that's going to be equal to 1 divided by x minus 3. And so now we can move to step 2 and locate the x that will make the denominator equal to 0. In this case, it's going to be x equals to 3. But also notice that from a domain standpoint, you have to consider the original function. And so you're also going to have that x cannot be equal to negative 7. And so there, you're going to have a hole. And so this function has a vertical asymptote at x equals 3, and it has a hole at x equals negative 7. And on my next video, note 42, I'm going to go ahead and show you how to draft this particular function, and you will see how this plays out. For my final example here for vertical asymptotes, I'm going to have h of x equals to x squared minus 25 divided by x squared plus 4. And in this case, you can see that the top can be simplified because it's a difference of squared, but the bottom cannot because it's not a difference of squared. And so in this case, our rational expression is already all simplified out. And so what number can make the denominator x squared plus 4 equal to 0? If you try to solve for x, this would give you x squared equals to negative 4, which taking the square root on both sides would have a negative number under the root. So in this case, x does not exist, or in other words, x is not real, and therefore you do not have any vertical asymptote for this particular function. All right, so next let's look at what you would do if you were to find horizontal asymptote. And so to find the horizontal asymptote, you're going to have three cases for a rational function. As we have up here, f of x equals to p of x divided by q of x. P of x and q of x happen to be polynomials. And so I'm going to call the leading term for p of x a times x to the power of n, and the leading term for q of x b times x to the power of m. In this way, p has for leading coefficient a and degree n, and q has for leading coefficient b and degree m. And so if you have a rational function that looks like that, then if m, the degree of q, happens to be bigger than n, the degree of p, then keeping in mind that the horizontal asymptote is showing you the behavior of the function at infinity, then as x gets bigger, because the bottom polynomial has a degree that is higher than the upper polynomial, you're going to have this expression on the bottom drawing faster than the expression on the top. And so you're going to have this expression eventually going to 0. And so in this case, y equals 0 would be your horizontal asymptote. And just a small parenthesis here, A horizontal asymptote is telling you the behavior at infinities, while the vertical asymptote is telling you the behavior at local points. Okay, and so if m, the degree of q, is equal to n, the degree of p, then both polynomials as x goes to infinity are drawing with the same speed, and so the x are going to cancel each other out, and all you're going to have left are going to be the coefficient a and b. And so in this case, y equals to a over b is going to be our asymptote. In our last case, if m is less than n, then the polynomial on the top, p of x, is drawing faster than the polynomial on the bottom. And so in this case, the function f of x will draw larger and larger to infinity, which means that you don't have any horizontal asymptote. But you might have other kind of asymptotes that we will talk about later. And so examples in this case is going to be f of x equals to 12x divided by 3x squared plus 1. And so in this case, m, which is equal to 2, is bigger than n, which is equal to 1. And so therefore, y equals 0 will be your asymptote. That's simple. Next example, I'm going to have g of x equals to 15x squared plus 4x minus 1 divided by 3x squared minus 1. And so in this case, since m, the degree of the bottom, is equal to 2, and n, the degree of the top, is also equal to 2, you have that the polynomials are equally distinct as x goes to infinity. And so therefore, your asymptote is going to be y equals to a over b, which is the leading coefficient of the top divided by the leading coefficient of the bottom. That's going to be 15 divided by 3. And so y equals 5 is going to be your asymptote here. For our last example, if you have h of x equals to x squared minus x plus 1 divided by x minus 1, then m equals to 1 is less than n, which is equal to 2. And so in this case, you do not have any horizontal asymptote, but you might have other kind of asymptotes, as we talked about earlier. And so with that, let's move into talking about the third kind of asymptote for this particular video, which is going to be the slanted asymptote. Okay, and so the first thing you should know about the slanted asymptote is that you can either have a horizontal asymptote or a slanted asymptote. You cannot have both. It's one or the other. And so as I pointed out before, if m is bigger than n or m is equal to n, then you're going to have a horizontal asymptote. But in the case where m is less than n, you might have a slanted asymptote. And so the first example that I'm going to give here is from our last example from before. So I'm going to have here h of x is equal to x squared minus x plus 1 divided by x minus 1. And so in this case, since m equals to 1 is less than n equals to 2, we established that we do not have a horizontal asymptote, but we might have a slanted asymptote. And so when this case happens, what you can do here is divide the rational expression. So you can write in a different format. And so in this case, I'm going to do a synthetic division. And if you want to know more about synthetic division, you can go ahead and check out note 39, where I talk just about that. And so here I'm going to put 1 on the corner here, because on the bottom you have x minus 1. And then I'm going to put the coefficient of the numerator, or the dividend, right here. And so it's going to be 1, negative 1, and 1. And so with that, I can bring the 1 down, then multiply 1 times 1 is going to be 1. Negative 1 plus 1 is 0. 0 times 1 is 0. Then 1 plus 0 is 1. And so with that, the 1 here is going to be my remainder, while the rest of the coefficient here are going to be representing the coefficient of my quotient. And so with that, I can go ahead and rewrite h of x as x plus 1 divided by x minus 1. And so with h of x written in this format, you can see now that the rational portion of this expression has on top 1, which has a degree of 0, and on the bottom, x minus 1, which has a degree of 1. And since in this case m is bigger than n, this is going to be going to 0. And so your asymptote here is going to be y equals to, the x stays, and then you're going to have plus 0. And that finally gives us y equals x. So in this case, the line y equals x is going to be your asymptote. It's going to be your oblique or slanted asymptote. While side note, in case you're wondering, x equals 1 is going to be your vertical asymptote here. Okay, so let me give you one more example to make this just sink in. I'm going to have here h of x equals to 15x cubed divided by 3x squared plus 1. And so in this case again, m is equal to 2 and n is equal to 3. And obviously, m is less than 3. And so in this case, you do not have a horizontal asymptote, but you might have a slanted asymptote. So let's go ahead and see what the division here gives us. And so since I cannot do synthetic division here, I'm going to go ahead and do long division. And if you want a reminder on how to do long division, check out note 38 where I talk just about that. And so I'm going to have here 3x squared plus 1. And under the division sign here, I'm going to have the dividend 15x cubed. And so now I'm going to look at the leading terms here, and I'm going to divide them out. And so I'm going to have 15x cubed divided by 3x squared. That's going to give me 5x. And so multiplying 5x by my divisor here, I'm going to get 5x times 3x squared. That's going to give me 15x cubed. And then I'm going to have 5x times 1. That will give me 5x. And so now I can go ahead and subtract these two expressions. The leading terms here are going to cancel first, and then I'm going to get negative 5x. And so, since 5x had a degree of 1 and 3x squared had a degree of 2, I can stop right here. And I can go ahead and write h of x as the quotient, 5x, minus the remainder, 5x divided by 3x squared plus 1. And so therefore, you can see here that my slanted asymptote is going to be y equals to 5x. And this rational portion of my function is going to be 0 because the degree of the bottom is bigger than the degree of the top. And so I'm going to have here that y equals 5x is my slanted asymptote. And so with that, we are done. And so as promised, my next video is going to be about how to draft rational function, so we can put some of these things in practice. And as usual, if you would like a copy of this particular note, check out the description below. If you like the way I break down the material, give me a thumbs up, and I'll see you next time. Bye-bye.